This video is factoring by grouping as we were doing in class. And the first thing we're going to do when we're factoring by grouping is making sure that we have all of the coefficients completely factored, or their prime factorization. 12 factors into 2 times 2 times 3. 9 is 3 times 3. 4 is 2 times 2, and then of course 3. We did something similar to that in class. When you're factoring by grouping, the first thing you want to do is you want to look to see if they have a greatest common factor. So you look all the way down the equation, and none of them have any numbers in common all the way across. This one doesn't have any 3s, that one doesn't have any 2s, so there's not a number part in common, and the last one doesn't have any A's. So since they don't have a greatest common factor, you would go straight to the fact that there are 4 pieces. Factoring by grouping is almost exclusively going to happen when we have 4 pieces. We start by grouping the first 2 together and the second 2 together. The first 2 pieces have a 3 in common, so we're going to factor that out. Open up our leftover parentheses. When you factor, and they also have an a squared in common. When you factor the 3a squared out of the first term, you're going to be left with a 4 and an a. When you factor the 3a squared out of the second term, you're left with a minus 3. Now bring down the sign between the 2 groups. Now 4a minus 3 doesn't have anything in common that we can factor out, but we're going to need a placeholder, so we'll use the number 1. When you factor 1 out of 4a, you're still going to be left with a 4a. When you factor 1 out of negative 3, you're still going to be left with a 3. Once we take our 4 pieces and turn them into 2, we look back to see what those 2 terms have in common. And it's exactly what you think. The parentheses part of it is actually the greatest common factor. So we're going to factor out the 4a minus 3 as our greatest common factor. Open up our leftover parentheses and then factor it. When you factor the 4a minus 3 out of the first term, you're going to be left with a 3a squared. When you factor the 4a minus 3 out of the second term, you're going to be left with a plus 1. They get easier as you go along, so let's look at number 3. For number 3, I'm going to write down the prime factorization of each number above it. Feel free to pause the video so that you can get the prime factorization done on your own. Now, they don't have anything in common all the way across, as we discussed in class, so we're going to go ahead and block them off into 2 groups. Because it's a 4-term phrase, factoring by grouping is the way that we'll need to factor it. Now, we're going to start with the first group. The first group has an n squared in common, so we'll open up our leftover parentheses. When you factor the n squared out of the first term, you're left with a 3n. When you factor the n squared out of the second term, you're left with a minus 4. Bring down the sign between the 2 groups, and then look again. What do 9n and 12 have in common? 9n and 12 have a 3 in common. So we're going to make that our greatest common factor in our second group. Open up the leftover parentheses. When you factor the 3 out of 9n, you're left with a 3n. When you factor the 3 out of a negative 12, you're left with a minus 4. Now we're down to 2 terms. We took 4 and turned them into 2. Those 2 terms have a greatest common factor of 3n minus 4. When I open the leftover parentheses, I can go back and say, if I factor the 3n minus 4 out of the first piece, it's going to leave behind an n squared. When I factor the 3n minus 4 out of the second piece, it's going to leave behind a plus 3. Remember, all factoring problems are checkable by simply multiplying right back through again. On number 5, there is nothing in common all the way across, so I'm going to start off by making this into 2 groups. The first 2 terms have an m squared in common, and when I factor it out of the first term, it's going to leave behind an m. When I factor the m squared out of the second term, it's going to leave behind a negative 1. I'm going to bring down the plus sign between the 2 groups. And then look for the greatest common factor in the second group. 2m and negative 2 have a 2 in common. When I factor it out, it's going to leave behind an m minus 1. Now remember, these are checkable at any point, so if I wanted to, I could quickly multiply back through to see if I'm right at this point. M squared times m is m to the third. M squared times negative 1 is negative m squared. Positive 2 times m is positive 2m, and positive 2 times negative 1 is negative 2. It's right so far. Let's keep going. Now we're down to two terms. What do these two terms have in common? M minus 1. When you factor the m minus 1 out of the first term, you're going to be left with an m squared. When you factor the m minus 1 out of the second term, you're left with a plus 2. And done. If I were to multiply these back together again, you're going to end up with the same four-term phrase. They may be out of order, but you'll have the same four pieces. I'll see you in the next video.